Hey everyone, happy Thursday. I want to quickly show you something that's pretty darn cool. I've been recently learning about operating systems, specifically all the components and how they make, but I'm not very good at sort of sitting passively. I really learn best trying to actually build something. And so this little folder here, what I'm trying to do is to create an operating system. Doesn't have to be super fancy, just something simple to understand what in the world is going on. So very logically, because I historically have destroyed my computer during certain times trying to mess with new things, I decided I would build this in a container. So what you're looking at over here is a Docker file to build a container that is going to do one simple thing. It's going to take a script that defines sort of the startup routine for a system. It's going to compile it, and then it's going to hand it over to an emulator to emulate a computer starting. To step back a little bit, when you start your computer, there's something called the BIOS, the basic input and output system, I think. And it's basically the set of functions or an API or routines, whatever you want to call it, that are going to let us do simple operations to sort of interact with like core memory. And it's really like old school and simple, and it's so old that we have to write scripts in this little language called assembly. That's this main.asm here that will describe the routine that we're going to take. And there's a particular section of memory called the boot sector that given that you put something there that has this particular magic number, and I'll show you that in a minute, the computer knows that it's a boot loading executable. So before I get too ahead of myself, let's take a look at what we're doing in this Docker file. We're basically going to use this tool nasm to compile our assembly script into a binary here. And we're adding this little tag for fbin to say that we actually want to create a raw binary. I didn't look at the other options, but if you don't do that, it'll create some more advanced kind of package that probably is what you would use if you're making like a real bootloader, but we're just making the really raw kind of stuff. And so here's the crazy cool part. You know, I was originally going to shell into the container and kind of play around, but I can actually give this emulator to be the entry point of the container, so when I run the container, it like boots up like it's a computer or something, and maybe it doesn't know that it's not a computer. Have you ever asked a container what it thinks? I don't know. That's good. Anyway, so we're going to be giving this binary for the bootloader to the emulator, and curses is just a little flag that helps with the display. Okay, so let's see, where's my other window? The second window is here. Okay, there it is. The second window we have over here is just so we can actually stop the container after it, quote, boots. And why is that? Well, after you would boot it, you would basically hand off to some kind of kernel on disk, and I haven't learned how to make that yet, so there's no kernel. It actually runs. Let me just show you something really quickly. Vim boot main. So what we're going to look at quickly is the assembly file, and I don't want to go through all of this in detail, but the cool thing about this assembly file is that all of the commands that you see are literally saying to move specific, decimals or hexadecimals into particular registries or places in the memory. This little thing up here is an offset, which basically will offset all of the addresses in this file by a certain amount, so it's in the right spot to be found. Any of these call things are different functions. This is a new line function, not a great name. Anyway, what I want to show you, definitely, this is super complicated stuff, and I'm terrible at it, so I don't want to like screw this up. But what I want to show you is this little command here. This actually means jump, and when you use the $sign like this, it's basically going to have it keep coming back to the last character. And what does that create? Well, it creates sort of an infinite loop. And then the last thing I'll show you is here we have this magic number. This is the magic number that says, hey, I'm a bootloader. That's what I do. So without further ado, we would first build the container, calling it VessOS. And I've already done this, so it should just be tagged. Don't have it running. It might still exist. So let's see. Docker, bet you it's still there. Call it booty. Haha. So we did have a booty. So now what we're going to do is we're going to run it. Docker run interactive. IT means interactive terminal, and this is so it won't give a weird message. Vanessa OS, and let's give it a name too. Docker run name. Gotta call it booty. Here we go. Woohoo! I love this. So we literally just ran our Docker container and we are looking at a boot screen, and this is probably like a really simple, stupid one, but here we see we're in 32-bit protected mode. I didn't look up what this string is. I don't know if this is a print from the BIOS or something else. It's probably something meaningful that I will just learn if I go to ipxe.org. And here's what I printed out, booting from the hard disk. Hello, dinosaur! Started in 16-bit real mode. So here's where we're just looping back in an infinite loop. So in order to kill it, we have to do docker stop booty, and then it's done. And honestly, that's it right now. And so why is this cool? It's cool because if you're a programmer, you operate on this very kind of tunnel vision in maybe your operating system of choice or your language of choice, and you always build things around that understanding. But when you realize that you can actually you can like step back a level and program the operating system, I mean, that's nuts. Like, what could I do right now with this very small amount of knowledge? I could do something stupid like create a bootloader that gave me a different message when I started my computer. Is that useless? Yes, but is it cool? Yeah, it's really cool. And I'm convinced that there are useful things to be built with this kind of understanding that I can't even anticipate or intuit at this moment, and that usually turns out to be the case with most things. But anyway, that's it. Let's see. I always like to say that a robot helped me today. So let's say what Vanessa robot name. Who was our helper robot today? It was the robot Salted Snack 9247. Thank you, Salted Snack. Okay, I'm gonna turn this off before I regret saying anything else.